The invisibility of plastics.
Yes, the invisibility of plastics. Tell me what you know.
The kind of invisibility of the plastic that we've thrown away has really picked up in the last, actually since Christmas. So before Christmas, everybody was really worried about the plastic in the ocean. Yeah, thanks to David Attenborough. And there were a couple of studies that had been looking for plastics on beaches and in rivers and saying how much plastic have we actually got here. There were some studies by University of Manchester that showed that some of the rivers in Manchester had like 40,000 parts of plastic per kilogram of sediment in places, which is quite a scarily large number of bits in a bag of sugar-sized pot of silt. And that was bad enough. And then after Christmas, there's been 2 more sets of research, one from Greenpeace, where they went to sample watercourses all over the UK, including high mountain lochs, and found microplastics even there. Oh, and actually in the water, not in the sediment, so not stuff that's accumulated over time, but stuff actually floating in the water. So then they're kind of going, oh, so that's then led somebody else to actually do air sampling and find that there's tiny little bits of plastic floating about in the air, and that's probably how it's getting into the water. So it is truly ubiquitous. We're quite focused on the large, bigger bits of litter because that's something you can do something about. But obviously the kind of invisible microplastic, the little tiny fibres that come from your clothing and all, and they're generally, some of that's going to be coming from the breakdown of larger items of litter, but most of it is just going to be the coincidental wear and tear of things that we take for granted. So who knew that brake linings were made from a plastic derivative? So every time you drive your car, and tyres also, there isn't that much rubber in the world. Most of your tyres are made from an artificial compound that's actually hydrocarbon derived, so it's a plastic. So little bits of tyre and brake lining are dropping on the road all the time, along with the particulates from your diesel exhaust, and then when it rains that gets washed off and it goes into the nearest watercourse. Some of it goes through storm drains to sewers, but most of it will just go to so-called natural watercourses, and so then it's in the sediment, it's in the water there. Everything from your house that washes off into the sewer goes through the water treatment works. They're quite good at trapping larger items, but I can't remember the figure. It's something like 50%, they reckon 50% of the smaller plastic particles that go into a sewage works pass through all the filtration and flocculation and everything and just come out the other end and get discharged to the river or the sea when they're finished. So there's a fairly high load of really small stuff, the fibres and things like that. So there's that. And a lot of that is from our kind of invisible use of just the fact that we're using plastics in so many everyday circumstances, like the fabric cover of the chair that I'm sat on, the cover of that desk. And so just the manufacture of that creates a load of bits, doesn't it, that go somewhere. But just generally having them around and using them then creates wear and tear. That means you're generating off bits that go into it. So,
yeah, true.
And we haven't worked out yet how big a problem that is.
No, but that's interesting if it's being found in the air in places where humans don't go an awful lot, because then that's travelling, and that starts to tell the story of how it does move around the world. What we don't look at so much or don't get a view of here in this country is that some of the waste that gets shipped abroad is burnt.
Yeah.
And it's burning, they're burning it because they don't have any other way of dealing with it.
Yeah.
But that burning is putting stuff into the air that is invisible.
Yeah, and that's then coming back to us.
Absolutely. It's just travelling around as the same as the water's moving around. Yeah. So actually, if the 3 places it can go are air, water and soil.
It's in all of them.
It's in all of them. But
and there's already a lot of it.
And the soil thing is about the only static thing as in where it...
So you'd like to think, but unfortunately, the load in soil is not static, it's moving. Because we're losing quite a lot of soil into rivers every time it rains, so that's taking microplastic into rivers and ultimately to the sea with it. So one of the papers that I've seen about microplastics and how big the issue is was making some estimates for how much would be going into water and how much might be going through other processes and ending up in land. Because a fair proportion of microplastics that go into sewage works are trapped by the processes. So let's say 50% of the microplastic is trapped in sludge. All that sludge is then spread as a fertiliser on land. So we've then added those microplastics to land. So all that land has then got microplastic in it, some of which could be taken up into the ecosystems and some of which will run off when it rains and go into the water and hence to the sea and off. And it's not uniform by population. So what the Manchester study found was you'd expect in a river system that you'd find the highest levels further downstream, and it would be a factor of population. So the bigger the population, the higher the levels of pollution downstream of them. But because of the way modern infrastructure works, and because a lot of this is road and sewage derived rather than direct inputs, it doesn't work like that. The highest concentrations were actually part way up the system at points where they were obviously, and they didn't look at where it was actually coming from, but you can imagine that there are points where either there are some kind of industrial inputs or there's a large sewage works discharging to the river at that point. Yeah, there must be some kind of point source halfway up the catchment that's causing stuff to accumulate there. And then because the stuff in rivers is only moving in high flow events, so what you're looking at is a record of really the last year's discharges since the last flood. Because what they found was they went back to the same sites after flood events and found that there was an order of magnitude reduction in the microplastic. So even the stuff that's settling out into the sediment in a river is processing downstream every time there's a flood, is being washed out. So what you're really finding in the snapshot pictures is the accumulation of what's gone in since the last flood, and then that just gets taken downstream. So you don't see a uniform progression down the catchment. And generally there was less upstream in the bits than there was downstream of the big cities, but there still wasn't uniform, wasn't as you would expect. There was some high, even in some of the upstream catchments there were high values for, again, must be some kind of localised source. That.
How have you found what is in the canal systems then? What's the difference between that and what's in the river systems?
So we've done some research by basically looking at what we're collecting and getting people, when they go out to do litter collections for us, to look at the waterways and record them and score them. So we focus predominantly on large-scale litter, but even there we found there was no correlation with population or even levels of deprivation, which you might expect. You might think if areas are more run down, people don't care about them some more, there'd be more litter. Didn't necessarily find that. We seem to have quite a nasty habit of dropping litter in places that are lovely simply because lots of people are going to them who can't be bothered to pick it up and take it home with them. So we found lots of litter, and it wasn't really correlated with anything obvious. We even found lots of litter in areas where we were doing lots of litter picking if you were sufficiently far away from the last time we litter picked. So if we're going once a month to do the litter pick, by week 4, so the week before we do the litter pick, there's loads of litter, and that kind of is why we're doing the monthly litter pick, because we're only going to places that were heavily littered. And we also took some samples of sediment to look for microplastics, but again we found no correlation between that and levels of litter or levels of population. So again it was a bit more random, that the really high levels of microplastics were in urban areas where you would expect them to be, but we also had urban areas that had much lower levels of microplastics than some areas that were maybe not super rural but were urban fringe. So there was a kind of, yes, the lowest levels were in rural areas and the highest levels were in urban areas, but in between there was no real correlation to population level. So again, because we believe the sources are sewage overflows, land runoff and road runoff, so you could be in a relatively urban fringe area, but if there's a motorway going past or something like that, then you could be getting lots of input from there. And we actually found one sample, so the most we found anywhere was kind of 5,000 or 10,000 parts per kilo, which is high but not as high as the peak levels they found in the rivers in Manchester. Still high enough to be worried about. And then we found one sample that had 135,000 parts in it, which is more than they found in any of the other samples. But 130,000 of those were a very particular small black particle. So there's obviously some kind of point discharge at that point that was causing the problem. So whether, I don't know, a bag of crushed rubber or something had got it, but so there was obviously some kind of point contamination there that was causing that problem there. But otherwise the levels were, yeah, thousands of parts per kilo, which is quite worrying. And what nobody has really, there's been enough work to say we know that larger items of plastic in the guts of some animals cause problems. So we know that seabirds, fish and whales and dolphins, that their guts can become blocked by items of plastic that they swallow but then can't pass out, and then of course that reduces their, we conjecture, reduces their likelihood of wanting to feed because they feel like they're full and so they starve to death. Clearly that's less likely to happen to us, but there's also the associated risk of all the chemicals that are linked to plastic, and what we don't know from the microplastic is the presence of a large quantity of microplastic also then going to link to the presence of a large quantity of organic chemicals that might be persistent and could actually be harmful. Because we do know that some of the chemicals used in plastic manufacture have very significant ecotoxic or mutagenic effects, and so if that is accumulating, then that would have an impact. But the real problem is, what do you do with it? Because big litter, I have a very simple answer to that. We can, A, it would be nice if we stopped dropping it, but B, we can always pick it up and get it out of the environment and stop it being a problem. The really small stuff, the invisible side of it from our invisible use of lots of plastic, then leads to this problem of, so what would you do with it? So let's say that we identified that having lots of microplastic in soil or water or sediment was a problem and was polluting the environment. How would you actually deal with that? Because it's ubiquitous.